Now let's take a look at area under and between the curves. Now we are given a graph of y is equals to f of x, and we are asked to evaluate the area under the curve from x is equals to a to x is equals to b. And we can see the shaded portion to signify the area. So the area is simply the integral of f of x dx from the lower limit of a to the upper limit of b. So we can take a quick examples of there. So we have 3 and let's evaluate them. So in the first instance, we are given f of x is equals to x from x is equals to 2 to x is equals to 5. Now, if we take a look at the graph of f of x is equals to x, we can sketch it to give us something like this. And we are asked to evaluate it from x is equals to 2 to x is equals to 5. And now we know that the formula for area is the integral from b to a of f of x dx. And b in this case is 5. From a to b. Apologize. From a to b. And b in this case, which is the upper limit, is 5. And a is 2. And our f of x is equals to x. Therefore, our area of y of f of x is equals to x. It is the integral of a, that is 2, to b, that is 5, of f of x, that is x, dx. What we have here, or simplified further here. Therefore, this we have to integrate x just like we did in definite integrals. And integrating x, we have x squared over 2 from upper limit of 5 down to lower limit of 2. Now we substitute our upper limit, and that is 5 squared minus 2 divided by 2, and the lower limit, that is 2 squared divided by 2. And this will give us 25 over 2 minus 4 over 2. And this will give us 10.5. 10.5, and area is given in terms of square units. The square units. Let's take another example. Evaluate the area under the curve from x is equals to 0 to x is equals to 2, given f of x is equals to x squared. Number 2, given f of x is equals to x squared, we are asked to evaluate from x is equals to 0 to x is equals to 2. So if we take a look at the graph of x squared, we'll have something like this. Then we are asked to evaluate from x is equals to 0 to, let's say, x is equals to 2. So we are looking at look at this area. Therefore, we recall that the area is given by lower limit of a to upper limit of b of f of x dx. Our b is 2, our a is 0, and f of x is x squared. Therefore, the area under the curve is given by 0 to 2 of x squared dx. So let's simplify this. And when we integrate x squared, we have x cubed over 3 from 0 to 2. And substituting our upper limit, we have 2 raised to power 3. And substituting our lower limit, we have 0 raised to power 3. This simplifies to give us 0. And we are left with 2 raised to power 3 over 3. That is 8 divided by 3. And this will give us 2.666. And the unit is square units. Let's take the final example. We're given f of x is equals to 7 minus x squared. And we are given the boundaries of x is minus 1 to x is equals to 2. Number 3, f of x is equals to 7 minus x squared, and x is equals to minus 1 to x is equals to 2. So simply, we know that our area is integral of a to b of f of x dx, and our a is minus 1 and our b is 2. So substituting that, we have integral of minus 1 to 2 of 7 minus x squared dx. Simplifying further, that means we have to evaluate the integral of 7 minus x squared. And integrating 7 minus x squared, we have 7x minus x raised to power 3 over 3 from minus 1 to 2. So we impute the lower limit and we impute the upper limit. Therefore, this will give us 7 into 2 minus 2 raised to power 3 over 3. That's for the upper limit. And now for the lower limit, that is 7 into minus 1 divided by 3. Simplifying further, this gives us 14 minus 8 over 3 minus 7 minus 1 over 3. So therefore this gives 14 minus 8 over 3 plus 7 plus 1 over 3. And this is equal to 18 square units. In our next video, we'll be taking a look at area between curves. So we might be given two curves and we have to find the area between the two curves.